So guys, now in this slide, we will going to discuss the event loop internal functioning. So as you can see on the slide, on the diagram, you can see these two gear system. These two gear system actually represents a thread, which is called an event loop thread. And this thread executes in an infinite loop. This thread can only suspend and resume, but this thread never terminates. Alright, so we have an event loop thread which runs in an infinite loop, and this thread can only suspend or resume, but this thread never terminates. Then the second thing that you see is a task array. A task array is an array of computations, and as I said, computation is nothing but it is a combination of function and its argument. So we will going to implement task array as a doubly linked list. So to say in other words, event loop is nothing but it is a thread plus a data structure called task array. That's it. These are the two components of the event loop. This thread acts on this task array. Alright. This green box represents the event loop library, which is completely isolated from your application. Alright. In your application, you may have several threads running. Now, when your application executes, one of the threads of your application submit the computation to the event loop. That computation is represented by this fnx and this argument x. So we will going to write this API and we will discuss the implementation of this API shortly. But let us assume that this API is used by the application to submit new computation to the event loop. As soon as this API is invoked by the application, the computation would be queued up into this task array. Alright. So using this API task create new job, the application submits the new computation to be executed by event loop to the event loop task array. Now event loop is nothing but it is a separate independent thread acting on its task array that I have already explained. Event loop works like a machine picking up the computation from its task array and placing it on an execution stack. So it simply fetches the new computation from the head of this task array and invoke the function f on this argument. Alright, this is what event loop thread does. And it keeps on fetching the computation from the task array until all the computations in the task array are executed. So event loop serializes all computations and discharges them one by one. Event loop thread will pick up the function f2 and fire it. Then after that, the event loop will pick up the function f3 and fire it. And it will keep on doing that until the task array is exhausted. It continues to do so until the task array is empty. And once the event loop task array is completely exhausted, the event loop thread goes into the suspension state. Alright, and it continues to be in the suspension state until the application queues up new computation into the task array again. Alright, so event loop resumes again if some application thread submits new computation to the task array. So now from this overall design, you can see that the event loop thread takes up the computation from the task array and fires it, whereas the application thread queues up new computation into the task array. So we can realize the producer-consumer pattern here. This is the common data structure. The application queues up new elements into this data structure, whereas the event loop thread removes the elements from this data structure. Alright, so it means that application acts as a producer, whereas event loop thread acts as a consumer. So this is a typical producer-consumer problem and nothing else. Your event loop thread is separate from your application threads. And it is for this reason, because different threads are acting on this data structure At the same time, we need to protect the enqueue and dequeue operation on this task array using mutex. Alright? So now let us discuss the sequence of events that takes place from the point of submitting a new computation to the event loop up to the point when the event loop completely exhausts its task array. So let us say that you have an application threads running happily, and at some point of time, your application thread submit a new computation to the event loop. As a result of which, in step number 2, the computation would be queued up into the task array. Now note that when the event loop task array was empty, the event loop thread was in suspension state. Alright? And as soon as a new computation is queued up into the task array of an event loop by the application, the event loop thread is signaled, or in other words, it resumes its execution. Then in step number 4, the event loop thread will pick up the first task from its task array. Alright? So that particular task is removed from the task array. And then in step number 5, that particular computation is fired by the event loop thread. So note that the computations are triggered in the context of event loop thread and not in the context of application thread. The application had hand over its computation to be performed to the event loop thread in step number 1. Now in step number 5, this computation is triggered. And you can see in this line of code that the computation itself is creating new computation again. So in step number 6, a new task is created and submitted to the event loop task array again. This computation has a function called bar and the argument is represented by arg1. Alright? So in a way, you can say that computation can give birth to other computations. In this line of code, we are creating a new computation and submitting it to the event loop thread again. And then this function foo runs to the completion by printing the printf statement. So step number 7 generates an output. This is my favorite. So now after step number 7, the first computation which was submitted by application thread to the event loop has been completed. Now it's a time for the event loop thread to look for the next computation present in the task array. So in step number 8, the second task is removed from the task array by the event loop thread. And as a result of which this computation is removed from the task array and is triggered in step number 9. And therefore, in step number 10, the new computation bar generates its own output called bar. So the overall output now is this is my favorite bar. Alright? Then finally, in the step number 11, the event loop thread suspends again. The reason is that the task array is now empty. It has no more computation. So this is how the entire cycle of event loop works. So if I ask you to draw a flowchart which represents the execution cycle of event loop thread, what will you draw? So here I can draw a flowchart. To start with, the event loop thread is in a suspended state and it continues to be in the suspended state until the application submit the computation to the event loop thread. So at this point of time, we say that event loop thread is in idle state, that is, it is doing nothing other than it is in the suspended state. And once the application submit a computation to the event loop thread is signaled, or in other words, we say that it resumes its execution. So when the event loop thread is executing and firing the computation from its task array, we say that the event loop thread is in the following state, that is finish wait. The event loop thread is waiting to finish its work. And the event loop thread, after firing each computation, checks whether the task array is empty or not. If the task array is not empty, it will keep on dequeuing the computation from its task array and keep on triggering them one after the another And as soon as the task array goes empty, then event loop goes into the suspended state again. And finally, once the event loop dequeue the computation from its task array at this step, of course the event loop has to go back and check whether the task array is empty or not, and continues to fire the computations from its task array until the task array is empty. So this is the flowchart which represents the execution cycle of an event loop thread. And we will going to implement this flowchart. So the takeaway from this here is that the event loop at any given point of time could be in any one of these two states. Either it is in idle state or it is in finish wait state. When the event loop is triggering the computation, then the event loop is in finish wait state. And once the event loop has triggered all the computations and its task array is empty, then event loop is supposed to move to the idle state. Alright, when I say event loop, I mean event loop thread. So now to begin with, from the next lecture video, we will going to start the implementation of event loop thread. Now we have understood that how event loop thread is supposed to work. We have now understood clearly the internal design and functioning of the event loop.